All right. Ooh. I don't know how to control this. Okay. I didn't finish this. I don't even know if I need to even say anything, but all right. So NumPy, you get. Wait, is this not working? Hold on. Okay, there we go. Okay, so I've got a ND array. So I got a NumPy array, and then you can do kind of these comparison things and get your true, false, Boolean values, right? So values less than 3, true, 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 false, 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 and the complement would be that. You know, what values are equal. And then likewise, you can subset that way, or you can run sums and take means for proportions. Okay. So we were the negation operator is this tilde, okay, and so you can do this when you use. I was just talking to Jake about this earlier today. When you use negation, okay, on Boolean operators, I highly recommend using parentheses so you can kind of keep track of what you're doing, okay? Because there is a difference between this and this, okay? What's happening here? So if I do this is what we're getting here, okay? So so the negation it's strange, okay? But just paste those down there. Okay. So you have stuff like that, okay? So let me just write, use the tilde or okay. Be careful when you don't leave off parentheses. Okay. I make a matrix 3 by 4. Okay, 3 rows, 4 columns, and you can do comparison operators on this, and it will make a 3 by 4 matrix of the comparison operators. Similarly, if we do the sum, you can get the column sums and the row sums as well using axis 0 or axis equals 1 using a NumPy sum. Okay, the normal when you're doing Booleans and stuff for like an if statement, you'll probably use and, the word and, or the word or. Okay, spelled A-N-D and spelled O-R. Okay, but you can also do bitwise or element-wise Boolean operators, and so this is I think this is similar to what we've experienced in R in terms of you've got 2 arrays, and you say, and you do element-wise and, okay? So here's A, which is true, true, false, false, and B, which is true, false, true, false. So when you do and, everything is going to be false with the exception of the very first entry, okay? And then with the or, everything is true except the last one, right? And then you have exclusive or, okay? And that means one has to be true and one has to be false. And if both are true or both are false, then you get false. Okay, And then the bitwise not, this negation operator is the tilde. Okay. You also have the any and the all, which behaves exactly as we would expect. Okay, and notice all of these, the any and the all use numpy, or numpy.any and numpy.all. Okay, and then the last is fancy indexing. Okay, regular old lists don't support fancy indexing. Fancy indexing is kind of the idea of subsetting an array, saying I just want the third element, the eighth element, and the second element in that order, or something like that. Okay, and so you can do that. You can say I want the values at index 0, index 1, and index 5. And so we're going to get 37, 12, and 5 there. Okay, so you can give it a list or an array here and subset the NumPy array using the fancy index. Okay, and similarly, okay, so here is just some 2x3 array that we've created by stacking two lists on top of each other, and then and I can use this to subset this. Okay, so if I subset a vector using a matrix of indexes, I end up getting a matrix with the values. Okay, so here I've got a 2x3 matrix, and in the first position, row 0 and column index 0, I get the value at index 1, which is 12, and so on and so forth. Okay. And you can also use kind of coordinates, x and y coordinates, to get what you want. So here I want row 0, column index 2, right, which is the value 2. This is row 1, column index 1, which gives us 5. And row index 2, column index 3 gives me 11. Okay, and so here I'm specifying basically the coordinates, what rows I want and what columns I want to select from the matrix. So I'm subsetting the matrix using coordinates of rows and columns. Okay, and so this is a way for us to extract values out, and and if you kind of combine that with kind of the Boolean operators, you can extract values with that meet certain conditions and things like that. Okay, and then the last thing I want to cover in NumPy is sorting. Okay, and we've got you've got sort and you've got Argh Sort. Okay, and these are similar to the sort and order functions in R. So here I'm going to create a NumPy array, just mixed up. Okay, the values 0 through 5, or 0 through 4, range 5. Okay, 0, 1, 2, 3, 4, and then x.sort sorts x in place. Right, so x.sort will sort it in place. Here is y. Okay, y is 5, 2, 1, 4. Okay, how does Argh Sort work? Argh Sort says if you want to put this thing in order, the elements need to go first element at index 2, which is the 1, element at index 1, which is the 2, element at index 3, which is the 4, and element at index 5, index 0, which is the 5. Okay, so this will, if you take y and you subset it based on d, then you'll get the values sorted in order, right? 1, 2, 4, and 5. Okay, because it's saying Argh Sort these. So that's sorting. as far as NumPy goes. Okay, and then, and what's really cool is that you can sort by a certain column. Okay, so here is, we've got a 4 by 6 array, 4 rows, 6 columns, all with just random integers between 0 and 9. And here we can sort sort these, okay? So sort basically each column of x, okay? So here, if we take this first column and we sort it, okay, then I get 1, 5, 5, 7. If I take this second column and I sort it, I get 2, 7, 8, 9. And then here, 1, 4, 6, 9, and so on and so forth. Or you can sort each row kind of independently of each other, and you get that. Okay. Okay. I'm going to do, okay, you can, I don't know if I did this, but if you want like the entire row 0 from x, you can subset using the colon notation. So I don't know, this is off on the side. So how would I sort this if I wanted to kind of arrange it by like the second column here? Okay, so I can do so let's pull out the okay, so this will give me the order in which I need to select this, right? And then I'm going to select the rows according to this. So I'm going to do, so this is the Argh sort for the column index 1. I'm going to plug that in there. And now we have arranged. So if I plug in the Argh sort for column index 1, and then I subset x using that, now I have arranged this by the second column, or the column index 1. Does this kind of make sense, what I've done here? This is probably other things. This is selecting a row. And here, the Argh sort for column index 1, and subset x by the Argh sort to arrange x by the column. If that makes sense. So I rearrange this according to what we've got. Okay, good. Great. Let me just go ahead and clear and run all. Hope this all works. something. No, okay. Something happened. All right. Now I'm going to open up 0303. So if you haven't done your git fetch and git merge or git pull or whatever it is, you can go ahead and do that. So I broke something earlier here. Okay, let me just. Let me just run through all of this. Okay, I'll save this. Close out. Okay. List comprehensions. So this was covered in your data camp, but it's often nice. Okay. List comprehensions I think are really great, unless you make them like overly complicated. But you can produce when you see one, you can see. I think they're fairly easy to read, better than necessarily trying to have to like decipher the loop itself. Okay, so you've got the expression that's going to go into the list comprehension, and then you basically say you do it for each value in a collection, and then you can apply some kind of condition for doing it, right? And it's equivalent to doing, for each value in the collection, if the condition, then append the expression. Okay, so here make a list of the squares. Save x power 2 for each x in 1 through 11. Okay. All right, I guess x in the range 1 through 11. If you want to make it an array, you just take the list comprehension and you throw it into the array. You can specify you only want it done for the odd numbers by throwing in a condition. Okay. You can take a list of strings and do stuff with them too. So you can do so here's a list comprehension applied to a list of strings. Doesn't have to just be numeric values. So here I'm going to say store the uppercase if the length of the string is greater than 2, right? So we're going to get rid of the words a and as, and then we're going to just be shouting bat car dev in Python. Okay. Anything that's an iterable, whether it be a list, a tuple, or a string, or anything else that's iterable, you can make a list comprehension here. So here I've got some kind of string that has digits in it, and we're going to go through each x in string. So x is going to treat Python's going to treat the string as an iterable, and each x is going to be just some letter. Okay. And we ask, is it a digit, right? So is it a digit takes a string argument and will return true or false if it's a digit character, okay? And then because we don't want to store strings that are digits, we don't want the string 9 and the string 6 and the string 3, we're going to throw that into the function int of x, okay? Oops. And so that pulls out the numbers, and they are treated as numbers in the list as well. It's pretty great, right? Okay. All right. So here I've got a dictionary. A is for apple, B banana, C is for cookie. All right. And if you recall what D items is, what do we get? So D items will be. Whoops. What happened here? Okay, D items is a list of tuples. Okay, so it has turned each of the items into a tuple with the key and the value. Okay, the key and the value here. And so what we're going to do is we're going to iterate over D items, which is kind of this list of tuples, and we unpack each tuple into the word key and the word value, or the object key and the object value. And then so the expression that gets stored is key is for value, okay? And then and we're going to do this as long as the key is not equal to b. So what do I get? I'm going to get a list, and what do I have in my list? The first thing, index 0, A is for apple, and the next thing? C is for cookie. All right, there you go. All right. Ooh. Okay, and just like a list comprehension, we can make dictionary comprehensions. Okay, exactly the same as a list comprehension, except the expression here we just have a single expression, and for a dictionary comprehension, you have a expression for the key and an expression for the value. Okay, but otherwise the same idea. Okay, so here I've got a list. Apple, mango, banana, cherry, okay? And what we're going to do is we're going to create a dictionary where the key is the word capitalized and the value that we store is the length of the word, okay? So here we're going to say for each F in fruits, so for basically each of these fruits, F.capitalize will form the key, and then the length F is going to be the value, and it's a dictionary comprehension because you got curly braces, and then there's a colon to separate the expression for the key and the expression for the value. All right, so we got apple 5, mango 5, banana 6, and cherry 6. Okay. What's the shortest fruit name? Kiwi has 4. Something shorter. All right, longest? I don't know, watermelon. What's that? What's longer than that? Okay. All right, think about that. Let me know by the end of class. All right, here we're going to take a dictionary where the key is the index and the value is the string. Okay, so here we can do that. All right, and what we can do is we can enumerate the thing. This is going to create a collection of tuples. Okay, and so this will say index 0, 1, 2, 3, so on and so forth, and then and now we can make a dictionary comprehension out of this thing, right? So if I take this, enumerate the strings, and we just create this, then now I've got an index mapping. Okay, I can say 0, index 0 is A, and index 1 is this. So basically it's just, because, here's the list, and, I could subset it this way, but now I've got a dictionary like this that basically gives me a mapping there. You can even, so here I said unpack the enumerate into index and val, and the way we're storing this is the key is the index and then the value is the value, okay? But what if I did the same thing but I flipped it around? Okay, so it's this exact same list of tuples, but what I'm storing is value is going to be the key, and the index is the value in the dictionary. Okay, so this is what this looks like. Okay, so over here we have 0. The key is 0, and it returns the value A. And here the key is A, and it returns the value 0. Okay, and remember, dictionaries are inherently unordered. Okay, dictionaries are unordered. All right, so if I take this dictionary, index underscore map, and I say give me back A, what will happen? Index map gives you back a key error because there's no key that has A, and so you can't take a dictionary and say what's in spot A. Okay, over here, the location map will say A has index 0. Is that all right? Okay. Here I'm making a dictionary using double star, okay? So this is kind of like for an arbitrary number of arguments. And so here I'm taking, making a dictionary with this and this. And so I get a big dictionary where I have both. I've got the words mapped to their index and also the index mapped to the words, okay? And then probably dictionary.update will modify the dictionary in place. So I'm going to take the location mapping and update it with the index mapping. This will permanently change location mapping, and we have this, okay? But you can, you know, I'm sure you can have creative ideas for what you can do with dictionary comprehensions or list comprehensions to kind of create something quickly and elegantly. Okay, even in a Jupyter notebook, you can technically prompt the user for input, okay? So here I've got name is equal to input, and when I run this cell, a little box appears, okay? And so I can type in Miles, okay? And if I hit enter, it will print out the result of kind of appending what I typed in into there, okay? If you take a look at what input is, okay, whatever you type in, even if it's numbers or some kind of expression here, it always is going to be seen as a string, okay, which makes sense, right? It's just whatever you type into the keyboard, it's going to get turned into a string. Okay, so here is a silly guess the number game. This is a little, I guess, a little different from your homework, okay? This one takes actual input in here, right? So we're going to say, what is your name? And then we're going to say, hi, so-and-so. Thinking of a number between 1 and 20. You have 6 guesses. That's way more than needed, okay? And you take a guess, and it's going to return guess is too low, guess is too high. And if the guess is correct, we will break out of this loop, okay? And then it will return back either you did it correctly or you didn't get it right, right? So hello, what is your name? Okay. I can never tell a lie. So here we go. All right, I'm thinking of a number. All right, you have 6 yet. All right, so we're gonna follow optimal strategy. Okay. All right. Okay. All right, we win. Okay. All right, we can do bad strategy. Okay. We failed. Okay. I mean, I guess bad strategy would just keep guessing the same number. There's no rule against that here. But that would just be silly. All right. So anyway, that's that. You can we can talk about functions and scope. This is like a favorite topic, right? And also covered in your homework already in data camp. All right, so it's got generous scoping rules, right? So if it can't find the value that the function has said it's going to use. So if you have to look at something in a higher scope, probably you've written your function poorly, okay? In general, ideally, all the values a function needs will be defined inside the function. But Python is forgiving, and it will look for higher scopes, right? So each function has a parent scope, which is where the function is defined, and so and variables inside the function only exist in the function. I think we're accustomed to this behavior because we've seen the same kind of behavior in R. So anyway, x, y, and z each take the values 1, 1, 1, or 1, okay? And this is where I really like tuple unpacking and assignment, right? Because in R, this would require 3 separate statements. And here I can just say x, y, and z are each 1, 1, and are each 1. Okay. All right, so here f is a function, and it doesn't take in any arguments. We're going to change y to 2, and we're going to return x, y, and z. So when I print the result of f, okay, I get the tuple with 1, 2, and 1. And if I print x, y, and z, I get the original values. The values in the global environment are not changed. Okay. Here, g is defined inside of f. F is going to return the value of g. Okay. G uses z as 3. Okay, and it says return x, y, and z. So, and it's not going to find any of these things. So it's going to search for the higher scope. It's going to find y is 2 and use that. And then, and it's going to search for x, and it doesn't find the higher scope, so it keeps climbing, ends up in the global scope. So print f is going to return what? One, 2, 3. And print xyz will return 1, 1, 1. Okay, great. Did we pass? Yes, okay. All right, so what about this? I'm defining g in the global, and I'm defining f in the global. And it says print f. Okay, so we're going to call f. F says y is 2, and then it says return g. So then it's going to call g, and inside g, z is 3. And so what will happen when I run this? What's that? I'm going to get 1, 1, 3 and 1, 1, 1 here, right? So what yeah?
If it's defined as y equals 2 there,
Uh-huh.
and then give one to g, does that value not carry over?
It doesn't. It doesn't. Yeah. So here inside f we said y is 2, but this value exists only inside of f, right? And here when we call g, okay, g is defined in the global environment, and so because g is defined in the global environment, when it can't find y, it's going to search the global environment for the value of y. Okay. Over here, g is defined inside of f, so when it can't find y, it first searches f and it finds 2. So the difference between this and this is that g is defined in the global here, so it uses the global value. And inside here, g is defined inside of f, so it uses the value 2, which is defined inside of f. Okay. You can use a keyword, okay? So instead of super assignment, okay, so R uses super assignment, but instead of that, Python will use kind of a keyword indicator, and we'll say, oh, we are talking about this variable z, which is the global z, okay? And so now, whenever we use z, modify the global environment directly, okay? So here I've got f, y is defined inside of f, we're defining g inside of f. Inside of g, I say use the value z in the global environment, okay? Now we assign the value 3 to z, and this affects the z in the global environment. And then we say return xyz. All right, so that's what g will do. So when we run f, it says y is 2 and return g, and then we look, okay, well, what is g? G says, well, assign 3 to the global z and return xyz. So what do we get here? When we run f, we're going to get 1, 2, 3, and when we print xyz, we're going to get 1, 1, 3. Yeah, 1, 2, 3, and 1, 1, 3. All right. So here, I'm going to define g. G has z equal to 3, and we're going to return xyz And if I run this, I'm going to get 1, 1, and 3. Here I'm going to define f, and we're going to say global y is 2, and we'll return g. So when I first run this, g will just take x, which is 1, y, which is 1, and z. It's going to find it here and return 3. But x, y, and z are unaffected in the global environment. So I get 1, 1, and 3, and 1, 1, 1. The x, y, z in the global environment are unaffected. Okay, in this one, now I'm going to call f. When I call f, f is going to access global y and change its value to 2, and then call g. So now when g runs here, what's going to happen? Well, it's going to say, well, let's return x, y, and z. So x, it doesn't find it. It's going to use 1. Y, it doesn't find it. Goes to the global environment, and this has changed to 2 because f has been run. And z, it finds it right here, and it's going to return 3. So here, when we print f, it's going to return 1, 2, and 3. And when we ask what are the values of x, y, and z, it's going to be what? 1, 2, 1, right? So we're going to get 1, 2, 3, and then 1, 2, 1. Okay, and then if I call g again, so back here when I call g, it returns x, y, z. Well, now it's going to return 1, 2, 3 as well, and 1, 2, 1. Okay, it's the same as before. Okay, here I've got p and q, which are both 1. And when I run f, and I call global s, okay, even though s is not defined in the global environment, calling this will create s in the global environment. Okay, so s is going to be 2, and then we ask for what is p and q, and we're going to get 1, 1, and 2. Okay, and s will exist in the global environment. Okay, why don't you look at this one and tell me what I'm going to get. Okay, what do we get? One, 10, 3, and then when we print, whoops. Oh dear, I held the shift key too long and now I don't know what I'm doing. Oh. Okay, what is this? How do I disable this? Turn on filter keys. Okay. Turn it off, please. Okay. So we get 1, 10, 3 and 1, 10, 3, right? All right. Non-local. So if you don't want to mess with the global, but you want to mess with a value inside the higher scope, you can use non-local. Okay. Non-local only works for functions that are inside other functions. Okay. If I try to use non-local inside of the f, it's going to give me an error. Okay, because it's going to say f is defined in the global environment, and you're asking for a non-local thing. That such a thing doesn't exist. Okay, because the only thing that's higher is going to be in the global environment. Okay, so non-local is only for the functions inside of other functions. Okay, so so here we've got 1, 1, 1 in the global. I have y is 4 in the in the function f. Inside g, we modify the non-local value, this y, inside of f to 10. We're going to modify the z in the global to 3, and we're going to return x, y, and z. Okay, so this will give back x, y, z. Okay, so f, now notice that inside f, we set y to 4. We define g, okay? We've defined g, but we haven't run it, okay? And then, so what's going to happen is it's going to encounter this line, print x, y, z. So this will print what? It will print 1, 4, 1. Then it runs G, and when it runs G, it's going to return 1, 10, 3. Okay? And then, so this thing will print two things. Well, actually, it will print one and return another. And then this will print X, Y, and Z from the global environment, which will be 1, 1, and only Z has been affected to 3. So we're going to get 1, 4, 1, 1, 10, 3, and then 1, 1, 3. Is that all right? With the kind of the order of operations? Yes.
If you have the print X, Y, Z before print F, F hasn't been called yet, so you still get 1, 1, 1.
Yes. If I printed X, Y, Z here, because F has only been defined, hasn't been called, I would get 1, 1, 1 before anything else. Yeah. Exactly. Okay. Oh, yeah. And so here is kind of the example that I'm talking about. If I've got F and I try to use non-local R, okay, the R, it's going to say it doesn't exist in the non-local environment. Okay, no binding for non-local R because F is inside kind of the global. So you can use global R, that's fine, but non-local R doesn't like that. Yeah, you can ask. I probably don't know the answer, but
when you make a copy of a function, like let's say that you've got a function that's defined in the global environment, and you make a copy of it inside of another function, then call the copy. Why is the parent frame still the global environment?
I don't know. I'll have to think.
Okay.
Yeah, sorry. No, it's all right. It's my bad because I haven't intentionally tried to break everything to find the exact edge cases of all of these things. So that is a good way to learn all of the intricacies, is trying to intentionally break things, right? So if you intentionally break things and you figure out where it breaks and why it breaks, then you can avoid having a bug where you don't understand what's happening. So it is a good thing. I haven't bothered with this yet though. So okay. So here we've got we can treat functions as objects themselves. Okay. So here I've got a bunch of stuff. Okay. I've got some state names with random punctuation and weird capitalization, okay? And I'm going to use some regular expressions here, right? So we're just going to do import RE for regular expressions. And what this will do, okay, is it's going to take each string, okay? We're going to define a function called clean strings, and what it's going to do is it's going to go through each element in the list, and it's going to apply kind of this series. We're going to say take the value and strip the white space and update the value, then replace these regular expression characters with nothing, okay, and then change it to title case, and then append the result to this empty list, or to the list called result, and then return the result. All right. So it's going to go through and it's going to clean up all of the state names and do this. Right. The only thing where it kind of didn't work out super great was South Carolina. There's 2 spaces in between South and Carolina, and I guess I didn't include anything to do that. Okay. All right. Here I'm going to just call a function. I'm going to define a function called remove punctuation. Okay, so remove punctuation is just basically this thing. Okay, you're using the regular expression to substitute either the exclamation, hash mark, question mark. Okay, with something else. And now I'm giving this a list of function. I'm not calling them, okay? I'm not calling them because there's no parentheses here to call the function, but I'm giving this a list of function names. So I've got string.strip, remove punctuation, which is a function, and string.title. So we are, these are functions, function names, but no, we're not calling them yet, okay? And so, so here, okay, so here's just what stripping the white space around Alabama will do, okay? But here, I'm gonna create a new function, and this new function accepts two arguments. One is the strings, the list of strings, and here is ops, which will be a list of operators, okay? Or a list of functions. And so instead of saying for each value in strings, do this, then do this, then do this, I've got a loop inside a loop, okay? It's going to say for each value in the string, iterate over each function and apply the function to the value and update the value. Does that make sense? Okay, so it's basically, we're going to be doing this, except instead of hard coding exactly what function I do and then what function I do and then what function I do, I've named the functions inside the list, and we can say for each value in the string and then for each function in this list of functions, apply the function and update the value. Okay, so I've got a list in a list, and we can do that. Okay, and so that's just defining this, and we're going to say, okay, take clean strings 2 and apply the clean operators. Okay, and we get this, right? Here I can give it a different list of functions. Okay, I've got string strip, remove punctuation, do uppercase. Okay, instead of I think I did string.title case. Okay, so we can change everything to uppercase, and then I've created what's called a lambda function. Okay, and the lambda function is basically like a function that's on the fly where it's not even worth typing out define. Okay, you didn't want to define a brand new function. Here you can just say lambda, and you just say, okay, we'll take x, all right, take a function, it's a function of x, and what I want you to do is find 2 spaces and replace it with 1 space. Okay, so we go ahead and we do that, and now, now it's run there, okay? So it's going to do that. There's something called map, okay, and it returns a map object, which is not useful, okay, but you can throw the map object into a list and it will split it out, okay? And so here I've got, so this is kind of like taking the name of the function and just applying it. It's kind of like apply to that in R, except you just take the name of the function that you want to apply, and you basically say you map it to every object inside this list over here, and that's what we get there. Okay. I got a couple examples of lambda functions, but I guess we're out of time here, so we'll call it a day. Have a good weekend, and we'll see you guys on Monday.